Hello there. I'm Tyler Vanderhoeven, one of the DevRel guys at the Stellar Development Foundation. I'm working on something kind of interesting. I'd like to show you. So we all are maybe, hopefully, familiar with the OpenZeppelin smart contracts. They've got a bunch of different packages that they've done for us. One of the ones that I love the most is the Soroban Smart Accounts package. You might know that I spent a lot of time a couple years ago kind of working on the pre-work for these smart accounts. It's essentially a smart contract address that's been configured. It's this protocol that allows you to kind of set up a bunch of different what they call context rules for this account, which allows you under different circumstances to authorize in different ways. So with different crypto addresses, in different methodologies, how long a context rule can be valid for. You can kind of just configure all of these different context rules that allow you to authorize different contexts being contract invocations under a bunch of different parameters. So you've got just basic kind of the context rule setup and configuration. And then you've got the different signers being external addresses, external cryptographic addresses, whether it's like a passkey, P256R1, or something more like a traditional G address using the ED25519 curve. Or you can also delegate signatures over to either a G address or another C address. So there's really those two different signer types. But then the one that I want to explore today is policies, which is essentially an entirely different smart contract, which can be configured under any sort of set of parameters. So it's its own interface, like that has a set of instructions for how it can be used. Policy has enforce, install, and uninstall. Enforce being the method that's called inside of your smart wallet, which then has to pass. The enforce method has to pass. So you can put any kind of custom smart contract logic inside of enforce. So it's a very, very powerful enabling technology for a smart account to then call some other smart contract, which has who knows what kind of logic. So I want to explore that a little bit. One of the use cases that I often think of is inside of Blend. I do a lot of stuff. The Blend being one of our DeFi protocols built on the network. For generating yield or borrow, lend functionality. But there's a lot of different things you'll want to do, deposit, withdraw, rebalance between different pools, convert BLND tokens into USDC. Who knows all the different things you might want to do, but they are limited. But I'm just always like logging in, right, every 7 days or something to reevaluate, perform all the same functions. So it'd be very nice to be able to like package that into essentially a policy that says all of these Blend functions, they're always approved. You can always call them, but that's all you can do on the account. So what I'd like to be able to do is take like one of those collection of like contract invocations, codify it into a policy that inside enforce, there's the claim yield, transfer, rebalance, all that logic. And then package that, and it could be a policy that's useful definitely to myself, but to anybody that performs those types of actions. So I would envision kind of a policy app store where there are many, many policies for all the different DeFi or services on this smart contract ecosystem inside Stellar, where users have crafted, or maybe developers have crafted these policies that very strictly enforce specific types of actions to their own protocol that then either some third party could control or just the user could store in their browser and not have to get like approval pop-ups all the time where it's like, okay, I've approved this before, why do I have to approve it again? It just opens it up, ironically, to a bit of risk to always ask the user to do the same things over and over because they get this like muscle memory of yesing everything. It's just a very small step to that transaction is modified for some reason in some way that then becomes nefarious, where if you could actually codify those interactions into a smart contract, they could never become nefarious. So the UX is better, but also the security is better when using a policy in force that's very strictly limited to a specific type of like previously approved interaction. And we see this is not like new. This is something that OAuth has had forever. Whenever you like log in, right? It's a 24-hour token that allows Twitter to read my tweets or post on my behalf, or Google, right? I can see my email, but I can't send emails. That's essentially what this policy enforcement is allowing us to craft. The issue here potentially is that there's a lot of different policies, and it may not be terribly straightforward what policies we want to enact. But I think between AI and transactions being very deterministic and easy to like traverse and see what happened in a particular transaction, for us to kind of combine those things into a policy builder that's informed by artificial intelligence and historical transactions to then like build us on the fly policies. So I've built a demo for this. Let me swing it on over. Make myself appropriately small. Okay, so we've got our wallet. I'm logged in with a OpenZeppelin smart account. I've got this ability to send XLM. So that would be like my basic action. So let's say we have an address. Let's just use, for sake of example, the testnet. We're just going to send to the testnet address. So I don't send to myself. I'll just send to some random address. This one just happens to be the native XLM address. And let's send, we'll just make it a nice even 9,000 after we send. So I'm using OpenZeppelin relayers, another service for gas list transactions. So we'll just make a send. You'll see the passkey pop up, approval. Again, this is a massive UX improvement over all of the installed wallets that have yucky pop-ups and seed phrases and nonsense. So no XLM got spent on fees. We use OpenZeppelin relayers. We just had to scan our fingerprint. It's a beautiful, wonderful experience. But like, we've approved it. This is allowed, sort of a thing. So what I'd like to do is like codify this into a policy. So that's where we'll go over to this policies interaction. We'll add a transaction hash, which I've just grabbed one that I've used in the past. That does an on-chain lookup of that transaction, figures out what exactly happened, and then from that extracts a pattern. This is all deterministic, nothing AI happening here yet. So we'll continue with this, and this then allows us to take that pattern and then like modify it. So give it a policy name. Maybe we want to describe it a little bit. I'll just leave those defaults for now. And then we have a contract address. So this is that native XLM transfer that happened. Sees that there's a transfer method. We could add additional methods that maybe come from this contract. It would be cool. Maybe another feature to do like a lookup. This one's a little bit tricky because it's a native Stellar Asset contract, so it doesn't actually have a WebAssembly file, but for other contracts, it would be a WebAssembly file. You could look up all the other methods. Maybe if it finds a Stellar Asset contract, it could just look up all the other methods that exist on it. But regardless, it can look that up, sees the transfer event, sees the arguments, and then you could select like what type. So any value for the argument. If you wanted to restrict it to only being to or from my address or the send address, we could do that. So maybe we want an exact match for my address, but we'll just leave that at any value. So I can send from anything to anything, and for a specific amount, I'm going to copy this and limit it. Let's do a range. So from, I don't really care, up to, we'll say 100 XLM. Remember the Shroops, 7 decimals. So we'll kind of just leave that there. We can add comments, would be kind of cool, right? So since this is going to be taken by AI, and then AI is going to build us a policy, we could add additional comments, which if our drop-down values were insufficient, we could add comments that then could be used by AI to make get us a better starting place for our policy. Any global rules we might like, and then there is a schema. I think it's important, especially for like the ability of AI to produce any sort of deterministic output, for it to be a bit more structured. So I'm still fiddling around exactly what the schema would look like, but some sort of schema that then like a skill or maybe an MCP, my AI could take a hold of and say, okay, this is the schema, and the skill is going to expect this schema and know exactly how to deal with each of these argument types. So it'll grab that. and then it'll go and we'll generate policy code. So this is using Kimi inside of a Cloudflare backend. We'll take in the schema, we'll take in the transaction, and from that, it'll do a bunch of thinking, and then it'll actually go and start writing a policy contract for us. Again, I'd probably want to attach better skills to this, maybe not use Kimi, but use something like Claude or Codex inside of a Cloudflare Sandbox, or however you wanted to craft it. Kimi's not the best at writing Rust, but again, maybe some skills could improve this. But one of the things that's neat about this that I have built and could continue to be improved is that we actually go and we test the contract, and if the compilation doesn't work, or the deployment doesn't work, or the tests don't pass, it'll feed that right back into Kimi and fix any bugs or errors that it finds. This is also like a starting place. You can edit the code. Again, I don't think I would actually turn this into a UI, like a web interface. I think I'd probably rather this be like an MCP tool, or even just a collection of skills that your AI code editor, code builder would use. So it wouldn't be a web interface, because the idea would be this is a place to start. We actually would need to go and dive in and write a bunch of comments and include, this is the place where we would start. We would modify from here, but it follows the interface pattern that we saw before, right? Where it's going to have the install, the uninstall. I think the top one here is probably enforce all of the correct functions for the policy contract. So it knows exactly what it's trying to build. All pretty cool. We could regenerate if we didn't like what we saw, but hopefully it's taken the schema and built it all, and this demo will work just fine. We'll test that in the sandbox. This is also a Cloudflare feature where it'll take this policy that we've written and then actually spin up a sandbox that has the Stellar CLI and Rust installed, and build the contract, and then run a suite of tests against the contract. Because everything is interfaced and strongly typed, it's quite possible, relatively simple, to run these tests against an ephemeral sandbox, see what kind of result we get back, maybe go back to Kimi and fix anything, or improve any issues that we found before we move on into the deploy section. This one can take a little while, because spinning up the sandbox and running all the Rust related tests and things can take a little bit of time. So through the magic of speed and technology, we'll go to the end here. All right, so it looks like uninstall, install, and enforce all succeeded. Fantastic. So then we can go and deploy it onto Testnet. So this basically optimizes, it builds and then optimizes our contract, and then deploys it onto, in this case, the Testnet, which then will give us a contract address, which we can then attach onto our wallet as a new context rule with this policy pre-installed. So there it is. That's the policy contract, and its WASM hash. Looks like it gives an interesting little what happens. And then we'll install this. We'll need to use our passkey, so the original context rule and signer, to approve and use this or install this policy onto our wallet. And there we go, policy installed. This is kind of the flow I would imagine, kind of like the OAuth flow, right? Where you're in some other dApp and it requests, hey, we have this policy. How about you interact with our dApp through this policy? And you could say certainly, or maybe you run it through a sandbox first and say, how about I build it? And then I'll install it to make sure it actually is the code that I expect, or what have you. All right, let's go back. If we go to our rules here, you should see we've got this new policy created. We didn't put any expiration on there, but we can do some different things with it. So that's all very cool. But then if we go back here, we'll notice we can sign with our number 0 multi-sig passkey context rule, or we can sign with auto policy. So when we send with auto policy, then because it's using a policy instead of the passkey, we shouldn't see any pop-ups. Now I will say this includes the policy, but then also a G address. We don't want anyone to be able to just call this without having some sort of cryptographic insurances. So just like we saw in the page here, we'll add a external G address as well as a policy. And in our case, when we were in policies and we installed the policy, I went ahead and stored a random G address, and it's just stored as a local storage key in the browser. The idea, I would imagine, with most of these context rules that have policies is they'll be short-lived, kind of like a session token. And so you would want to store that cryptographic key just in the browser somewhere as like a token. And then after the 24 hours, you could flush it and the policy is no longer usable, and the user would need to reconnect using their kind of like super main, maybe passkey wallet. Anyway, let's go ahead and do another transfer. And if our code actually wrote correctly, if we try and do 101, we should get an error because we should have capped it at 100. So if we do 100, this should work just fine. And we'll notice this drop. And that's the only thing that policy will permit. If we tried to call anything else and use that context rule for anything, we'll get that error because the policy has been hard coded to only allow XLM transfers. Actually, I think the way that we coded it, it'll only allow transfers with 3 different arguments of any type. So maybe not the best policy, but hey, it's kind of cool. And I think shows the power again of this like automatically building a policy from the starting place being a transaction hash. Kind of fascinating. So anyway, that's what I've been building, or vibe coding. I guess Claude's been building it for me, but lots more we could do on this front. I think it's super interesting, this idea of kind of pairing agentic code generation with some deterministic like schemas and actual on-chain transactions. There's a lot of really cool stuff that we can do here to make Web3 far more usable and secure. So be inspired. This is all open source. I think if you go to my GitHub here and you just go to PollyWallet, the code's all available. You can fork it, use it, explore it. I don't know how much further I'll go in this direction. I do think it's really, really cool. But there are smarter brains than mine that should take this and run with it. All right. Well, enjoy, and we will see you in Code Land.